Section 5.3 is on the sum and difference identities for cosine only. Okay, if you look at the first chart here at the top of the notes, we have two identities. The first one is the cosine of a sum. Okay, so I have cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times sine of B. And then we also have the cosine of a difference. Cosine of A minus B is equal to cosine of A times cosine of B, same thing, except plus sine of A times sine of B. Okay, this is one of the identities that I would not ask you to know by memory. I would just ask on this test, on this Chapter 5 test, that you be able to recognize when to use this identity. Okay, we'll work some examples in just a minute. Next, underneath, we have cofunction identities. Remember, two angles are cofunctions if their sum is 90 degrees or pi over 2 if you're dealing with radians. So we have cofunction identities saying that we have cosine of 90 minus theta is equal to the sine of theta. Okay, same thing for sine and cosine here. That tells you that they are cofunctions of each other. Just let me give you a little side example of that. This is telling me that if I have the sine of, let's say, 30 degrees, sine and cosine are cofunctions, so therefore the sine of 30 will equal the cosine of 90 minus 30, okay, which is 60. Okay, so the sine of 30 is equal to the cosine of 60. Okay, the angles just have to add up to be 90 degrees. Okay, we use 30 and 60 a lot because we work with those on the unit circle. You know, it could very well be the sine of 10 degrees using my cofunction identity. The sine of 10 degrees would equal the cosine of 80 degrees. Okay, the angles are complementary, they add up to be 90. But sine and cosine are cofunctions. Look at our list here. Cotangent and tangent are cofunctions. So this same relationship would be true for those. And secant and cosecant are cofunctions. Okay, and then also it just gives you a reminder, this works for radians as well, so it could be that you would use pi over 2 in the place of 90 if your angle was in radians. Okay, so number 1 is actually dealing with the first identities we talked about. It says use the appropriate identities to find the exact value for the cosine of 75 degrees. Okay, I realize you can type into a calculator cosine of 75 degrees and find your answer, okay? But it would not be an exact answer on most calculators. So we were going to use algebra and use our identity to find the cosine of 75 degrees. I would want to go back and say, alright, how can I break this down into two smaller angles? Okay, common ones that we've talked about in Chapter 4. The cosine of 75 degrees would equal the cosine of 45 degrees plus 30 degrees, correct? Okay, 45 plus 30 would give me 75. So this is kind of like my A and my B that's in the formula listed above. Okay, so I could use that identity to say that cosine of 75 degrees is equal to, go back and look at your formula, cosine of A, which is 45, times cosine of B, which is 30 degrees, minus sine of A, which is 45 degrees, times the sine of B, which is 30 degrees. Okay, I know this looks kind of long, but if you go back, and you may need to even pause the video and go look at your unit circle from chapter 4, but you should know your values for these angles, okay? So we can have cosine of 75 degrees is equal to cosine of 45 from the unit circle is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. And then the sine of 45 degrees is square root of 2 over 2. And the sine of 30 degrees is 1/2. Okay, again, if you don't have a clue where I got these values from, you need to go back and look at the unit circle in chapter 4. Okay, and also you could use your right triangles, 30, 60, 90, or 45, 45, 90 triangles as well to find those values. Okay, from here we're just going to simplify. Cosine of 75 degrees, if I multiply, I'm going to have square root of 6 over 4 minus square root of 2 over 2, not over 2, square root of 2 over 4. Went a little too fast. Then we could subtract. We would have square root of 6 minus square root of 2 all over 4, just to write that as one fraction. So that would be my exact answer, which, like I said, you probably wouldn't be able to find with just a calculator. Okay, number 2, same type of problem. Use the appropriate identities to find the exact value for the cosine of 15 degrees. Well, now think about, would we have two of our common angles that would add up to be 15? No, but we might have some that would subtract to be 15, okay, like 60 and 45. So we would use the second identity here, the difference, cosine of a difference, to say that the cosine of 15 degrees would equal the cosine of 60 degrees minus 45 degrees. Okay, we could all say that that is true. So then, again, 60 would be my A value, 45 would be my B value, and so I'm just plugging into the identity. This would be cosine of 60 times cosine of 45 degrees. Right? Remember, it's always the opposite. If this is negative, then it's going to be positive. So plus sine of A, sine of 60 degrees, times sine of B, sine of 45 degrees. Okay, then again, you've got to remember these values. What is the cosine of 60 degrees? Okay, it's 1/2. The cosine of 45 degrees is square root of 2 over 2. The sine of 60 degrees is square root of 3 over 2. And the sine of 45 degrees is square root of 2 over 2. Multiply, so we would have square root of 2 over 4 plus square root of 6 over 4. Almost looks the same as what we had on number 1, but it's square root of 2 plus square root of 6 all over 4.